Good morning, students. The next topic we are going to see is about the bending of cyclist in the curves. Okay, so consider a cyclist who is just moving around the curve, and that cyclist moves with the speed v. The center of gravity is considered to be c, and we are considering with the two axes, which is OC along the x-axis and the vertical line from O along the z-axis. So this is cyclist who is moving in the circular path. Okay, so when he is moving in the circular path, we can consider that this point there are two forces acting. They are, first one is the normal force, and because of the friction in the road, okay, that is said to be the frictional force F. Okay, and when you consider this man, okay, this man has a two force. They are, first one is the downward gravitational force. That gravitational force is mg, and he is moving in the circular path, and so he experiences with a centrifugal force. Okay, and that is represented by mv square by r. So we have the four forces: normal force, frictional force, gravitational force, and the centrifugal force. Okay, so these four forces are acting on the body when any person is moving in the circular path. So the four forces are gravitational force mg, normal force n, frictional force F, and the centrifugal force. Clear? Now represented it with the help of a diagram. So we are representing like this, okay? And this is normal force, and this is a frictional force. And when you see here, this is a downward gravitational force, and this side we have the centrifugal force that is represented by mv square by r. Okay. Now this how we are going to write is this term into this side, and same way this term into this opposite side. So we'll be writing this as mg into this perpendicular side, so which is written as AB. Okay, when we take with this side, that is written by m v square by r. The perpendicular side is BC. Okay, this is how we have to write on both the sides. Okay, so that side and the opposite side. Okay, and this is considered to be negative. Why we are considering it as negative is because it is against the direction, and this is considered to be positive. Okay, so these are the main things you have to know in this. And from the same diagram, consider it to be a triangle. Okay, so considering this to be a right angle triangle here, so it is right angle at the angle B. Okay, at the point B, here is C, sorry, A, and here is C, and here we have the angle theta. Okay, so from this we are going to find the values of sine and cos theta. First, find the value of sine theta from this. What is the formula for sine theta? Is opposite divided by hypotenuse. Okay, so opposite side here is AB divided by hypotenuse is AC. Okay, same way cos theta is equal to adjacent. So what is the adjacent side is BC. Okay, so it is BC divided by hypotenuse, again it is AC. Okay, from this if you want AB alone, this can be written as AC into sin theta. Same way here also, if you want BC alone, this can be written as AC into cos theta. Okay, so these values you'll be using it. This sine and cos formulas you have to know. So taking with mg into AB, that mg into AB, as I've told you, that is taken as negative, and so it acts in the clockwise direction. Okay, and this mv square by r into BC, that is taken as positive, and that acts in the anti-clockwise direction. Okay, so taking this positive as well as the negative signs, if we write the equation for this, we get minus mg AB plus mv square by r into BC is equal to 0. Now bring this term to other side, so this becomes as positive. Okay, and from the triangle, as I've told you, from the triangle we have to find with the sine and cos. Yeah, so taking with the sine and cos values, now we are going to substitute AB. Instead of AB, substitute this value here. Instead of BC, substitute this value here. Okay, so we'll be getting it as mg into AC into sin theta, which is equal to mv square by r into AC into cos theta. Okay, both the sides AC gets cancelled, m also get cancelled. Okay, bring this cos down, so sine divided by cos, so we'll be getting it as sin theta divided by cos theta, which is equal to, so that side we are having with the term v square. Okay, here we have it g. Okay, so bringing it down we get v square divided by rg. Okay, sin by cos can be written as what? Tan. So tan theta is equal to v square by rg. Bring this tan this side, that becomes this tan inverse of, so tan inverse of v square by rg. So this gives your necessary condition for any cyclist who is moving in the circular path. Yes. So while negotiating a circular road r and the velocity, a cyclist has to bend at the angle such that to stay in the equilibrium. So maintaining these values of velocity and the radius, that man can move in the equilibrium position. Clear? Thank you.